So this is a projectile motion example for horizontal projectile motion. A cliff diver has jumped from a cliff 27 meters to the water below. They must land 3 meters from the edge of the cliff. How fast must they be moving horizontally when they jump to hit their target 3 meters from the cliff's edge? All right, so I've already shown a picture here with 27 meters down, and then they start off horizontally at some unknown velocity. And that's what I need to figure out. And they're going to land in the water 3 meters away from the edge, which is the deepest part of the water. So before I really get into this, what I need to do is make up my table of my unknowns. So I'm going to use my kinematics givens, and that's going to be VO, X, T, V, A, or as my kids like to call it, Vox TVA. And I'll need some vertical givens to begin with, and then I'll do the horizontal givens. All right, keep it simple. So vertically, initial velocity, well, they're not going up or down initially, so that's going to be 0. The distance down to the water is going to be negative 27 meters, because up here is where x naught is equal to 0, where the motion starts. So x naught's not going to be in any of my equations because it's 0. Time, I don't know. Velocity when they hit, I don't know. Acceleration, I always know that on the Earth. This is jumping. Let's see, try this. Negative 9.80 meters per second squared. Horizontally, everything going left and right. Let's see, I got 2 numbers horizontally. I know the initial velocity is what I'm looking for, and the distance is going to be 3 meters. Now, in terms of my equations, I know horizontally I have only one equation that I need to work with. That's the range equation. Range is equal to the horizontal velocity times the time. And that's what I'm after, because this horizontal velocity, V naught, in this equation, this is the same V naught that's up here. So they're the same V naughts. So if I could just find that. To find that, I need to find the time in the air, because I know if I use my vertical givens, that time and this time are the same, and that's the time that I need. So that's my task. Find the time in the air using the vertical givens. All right, VOXA. So I need an equation to use. I'm going to use the longer equation. That's going to be x equals x naught plus V naught t plus 1/2 AT squared. Now in this, I know a couple things. Vertically, x naught's always going to be 0 for us. Vertically, the initial velocity is going to be 0, so that's going to go away. That's going to make my equation really simple. X is equal to 1/2 AT squared. And I'm just looking for the time. So I'll just go ahead and throw in my numbers here. X is going to be negative 27 meters is equal to 1/2 negative 9.8 meters per second squared. And that's all times time squared. So I'll multiply both sides by 2, divide both sides by negative 9.8. And when I do, I'll get the time to be 2.347382389 seconds. So that's how long the person's going to be in the air. That's how long it takes to fall 27 meters. And the time it takes for them to fall 27 meters, they're also going to move horizontally 3 meters. So that's going to be my time that I'll put over here. And I'm not going to write it all in the space because I don't have room. So I'll just write some of it, 2.347 seconds. All right, that's the time. So I have the horizontal velocity is what I'm after. I have the time, and the range is up here. There's the range, and there's the time, and I want the horizontal velocity. So that's what I'll find next. All right, so let's see. Range is equal to V naught times time. The range is going to be 3 meters. That's equal to my unknown V naught, and my time, 2.347382389 seconds. All right, so my initial horizontal velocity is 3 divided by the time with all my decimals, and that's going to be 1.28 meters per second. So that's how fast the diver has to be moving horizontally. That's slower than you walk. So they barely move horizontally to make the mark.